Okay, so there's three things. Part one, which is more of a research. Part two is more of a build, bit of research as well, and the theory test. But this one's probably the hardest one of the lot. You can see here it is. It's right there. It's part two, and I'll open it up and we'll discuss it right now. But you'll notice that there's some additional learning resources down here. They're the actual files that you might need to access. Okay, so it talks about using certain things, then they're there. So what do we have to do for part two? So remember, we said that if you remember the 5 ICW assignment, that was if you imagine that happened, let's say 2 years ago now. Okay, so that's all working well. What you built for this this customer, it's been working, it's functional, and now they've called you back 2 years after the fact to actually add more functionality, to extend the network, to incorporate that second site. If you remember, we spoke about there being two sites, the Elizabeth site, which is the production site, and the LA site, which is the head office. So in this assignment, if we scroll through a little bit, we're going to be covering viruses, malware, networking threats, physical security, vulnerabilities, network hardening, and all those security additions as well. So it's not only just building this network, it's building this network and also providing security for some of the access. So again, it's one of those assignments where you have to get everything right, just like it's a real life job. You don't finish the project and be 70% done. It's finished, it's 100% done, or it's not done at all. Okay, you'll see that the network diagram changes a little bit here. Okay, so this shouldn't be too unfamiliar, but if we actually look at this picture, this is how you'll visualize what the end goal is. Okay, there's probably another computer that should be here on the internet, which is like a sort of symbolizes a home computer or someone on the road. But really, you have two sites, the LA site and the Elizabeth site, and that's what you're going to have at the end of the day. At each site, you're going to have a domain controller, a file server, and a remote access server. Okay, so basically we know what domain controller does, we know what a file server does, but this remote access server we're going to learn about in the next few lessons. And what this remote access server is going to do is going to allow us to remotely access these files through what's called a VPN. Okay, so what does that mean? That means if I'm on the road, I'm off site, I'm in a meeting at a customer's site, I can still use my internet connection, go back and access the resources that might be here on the local resource. We also are using this VPN or these RAS servers or remote access servers to connect the two sites up. So basically the idea is these two sites are, as you can see, geographically separate, okay, by probably almost 20 Ks. Okay, so how do we make them be able to communicate with each other securely? Okay, through this VPN, we're going to connect the two sites up as if they were two networks, just like you might have learned the different subnets, two subnets on the same network. Obviously, in this case, we're not going to have a dedicated line because basically, just to get a dedicated line, connect this building to a building across Curry Street, it's going to cost you about $20,000 just to set up that line. So for this 20 kilometers, it's not feasible for a small company like this. Okay, so they have to take what they've got, which is an internet connection, and they're going to use this a function of Server 2016 and create a VPN, which will provide security and privacy as the information is exchanged. So you'll notice that there's a domain controller here, but it's RODC instead of just a read-write domain controller over here. So I think we've sort of covered that in our worksheets already. That's a read-only domain controller. So what it means is that it doesn't actually store your passwords here. It just allows for authentication, but at the end, behind the scenes is actually still communicating with this domain controller to actually grab those passwords as they're required, but not storing it here. So it provides security because obviously at this production site, it's not as secure point of view of people being able to just bring their devices in there without being maybe detected. So that's why it's a read-only domain controller. You also have this file server. Obviously, some of the files that's here will also need to be here. Okay. The reason for that is because people work across sites and they want to be able to collaborate. And also, you don't want it to be out of date. One of the problems with what we talked about in File by CW was when you have more than one copy of files, you have different versions, don't you? So what we're going to do is we're going to use DFS, a distributed file service, okay, to actually use this to replicate the files from these two file servers. Okay, and that's going to go through this VPN. So the VPN is critical for all this information. The domain controllers can't talk to each other. The file servers can't talk to each other. The computers can't talk to each other without this VPN. So this VPN is really important. So if you look at it, it's set up similarly, but instead of having just one subnet, you're going to have two subnets. And these numbers I'm going to give you in class. So everyone's going to have a different number. But if you, so you see how this is a XX and this is a YY. I'm going to give you two numbers. And you're going to use one for the Adelaide campus or site and one for the Elizabeth site. And that's your numbers. Your numbers are not going to be the same as anyone else in this class. So you'll have a different set of configurations. Obviously, your domain, similar to last time, is going to be your surname, ec_yoursurname.com. And if you look at the virtual hardware, it's just a basic virtual hardware. You probably remember from last time is not too different. Except that we're not going to do RAID here. Okay, so last time we concentrated on RAID because obviously that was what the subject taught you. So in this subject, we know you know how to do RAID, so we don't care about RAID. Okay, in real life, you probably would still, same as last time. But in this case, we're going to move past that to sort of make it easier for you rather than have you do all those kind of things. So you notice that there's a domain controller, 2 hard drives, file server, 2 hard drives, and don't worry about doing anything with RAID or storage pools like that. There's a remote access with 1 hard drive, and there's actually two network cards, 2 NICs. Okay, obviously if you look at the picture, there's 2 NICs because there's one that's pointing to the inside and one which is pointing to the outside internet. Okay, obviously we don't have access in this classroom to the actual internet. What we do have is the bridge network. You guys all understand the bridge network, which is the physical network in this class, and we have a host-only network. Okay, host-only, which is only internal to the physical computer that we're virtualizing it. So you'll realize that, hey, we need 2 internal networks, don't we? We need one for Adelaide and one for Elizabeth. They can't be on the same network, otherwise what's the point of the VPN? Okay. So they're on different internal networks. So the Adelaide one will be on VMnet 1 and the Elizabeth one will be on VMnet 2. And if you've done your for IVM, you should know that there's a difference. They're both internal, in this case, host only, but they're different internal. It's having 2 different physical switches and plugging your computers to 2 different physical switches, okay? But the commonality is this bridge network, which to us is going to be our internet, okay? This bridge network. If I keep on scrolling, you also have a Windows 10 client. You don't need to build this, okay? I know last time some of you guys installed the Windows 10 as well. Really, we're not interested in if you know how to install Windows 10 or not, because that's something that's way back when you started in FreeESS. So really, you can use our Windows 10 that's given to you on the L drive, but these servers, okay? These servers, the actual server virtual machines you must build. Okay, because we don't want you to take my work and do something to it and make it your computer. You need to build this just like you would in a real project. All right. So you'll notice there's a naming convention as well, just like we spoke about in our 5ICW subject. Okay, in the 5ICW subject, you got to come up with a naming convention, but you're probably rarely going to do that. Okay, unless you're the head network designer or network architect, you're not going to do that. What you're going to do is you're going to take what someone's given you and use it. You're going to take what's company policy and follow it. Okay, our company policy, if you notice, is XX, the name of this, the acronym for the site, and then the major function of the server, which is, in this case, read-write domain controller. So this XX, in this case, will be substituted by your initials. Okay, for me it's going to be AZ, ADL, RWDC. Okay, so you're probably going to you're going to say, what if I use something else? Well, it's just like in the workplace. If you use something that's totally off the policy, as in this is the policy, and you've used the instead of calling it AZ, ADL, RWDC, you call it Bob, for example. Yeah, what's your boss going to say if you're going to use a totally different naming convention to what he's given you? He's going to say that's not our policy, isn't it? So therefore, even though it sounds picky, but I'm going to make sure that you guys are following company policy, and that's part of the requirements of the competency, is to be able to follow company policies. Okay, and the company policies is that you substitute your initials here, and you use this naming convention of site plus major function, as specified here. Okay. So when you do create your virtual machine, make sure they're named correctly. And there's two things, okay? So in a virtualized environment, okay, so if you were doing this in a virtualized environment data center, what the best practice, or the policy again, or best practice in general, is that you keep the computer name and the virtual machine name exactly the same. You get me, guys? So there's no confusion when you're referring to this virtual machine or that computer, because we know the computer name is what we use inside the operating system, and the virtual machine name is what we use in the virtualization software. So for example, we probably haven't followed this too well here. You can see that there's my server. That's my actual virtual machine name. There it is. But the actual computer name is actually just server 1, isn't it? So really, if I was following the policy or best practice there, they should be like that. You get me, guys? So there's no confusion. The worst thing in a data center is when you have 100 virtual machines and then there's actual computers in the network to not understand which one's which. Okay? So therefore, when we're checking stuff off for like computer names right, domain names right, I'm gonna make sure that you are following the company policy. Okay? So just be warned, that's one of the requirements. If we keep on going, you'll see that the first part, Active Directory structure, is exactly the same as 5ICW. Exactly the same idea, same department, same users, and obviously should be similar groups, shouldn't it? Okay? Except that instead of actually needing you to create templates and to do home directories and stuff like that, that's not required. Just users, groups, just keep it simple because we've assessed that part already. So we know you can do that. Then the resource sharing, same thing again. We've simplified it a little bit. We've got EC documents still. We've got the department folders, and we've got one printer instead of the two. Again, we know you know how to do this, but you still have to do it because we're going to use this for other things later. Okay, we need those users first of all for just users to log into Active Directory. We need groups to be able to access these resources. We need these resources in order to use DFS to replicate resources. And we need these resources in order to use group policies to actually connect to them automatically. Okay? So basically, even though you say, oh, why are you making us do it again? Because we need these things to do other things which are a little bit more advanced. Okay? It's like, just because you know how to walk doesn't mean we always have to run. Okay? We have to sometimes walk in order to be able to run later. All right, then we get into things which weren't in the last assignment. Password policies, you already know how to do that. Okay, we've done that. Then there's group policies, which is what you should have started last week in the lesson that I was away. Okay, but obviously there's two parts of the group policies. There's two worksheets. So we'll talk about that one next lesson, the second part. There's an asset register. Okay, this is an interesting one. This is not something you do on the computer straight away. If you don't know what an asset register is, it's like, how do you know what equipment, what assets you actually own in your company? Do you just buy it and put it out there and have no idea what you've got? That doesn't sound like it's a good practice, does it? How do you know if something's missing? How do you know if it's a common problem with all the same type of assets? You know what I mean? What if you got a batch of computers and they all have a common fault? How would you know which computers have that fault if you don't even have a register of what computers you got and what models and stuff like that? So the whole point of asset registers for a couple of reasons. Okay, first of all, is for security. So we have this computer. We can assign this computer to a person, and then that person is responsible for that asset. At the end of the day, when he leaves or when we upgrade his computer, he must sign back the asset. You get me, guys? So basically, this way, we don't have things that just go missing. You get me? If no one knows what's actually purchased and what we've got, who's to know something's missing? You get me? So this is basic physical security. The other thing is that whenever we have an asset register, it's like a database. In this case, we're making it simple, it's just a table, but we have to have an asset number. You notice that on all these computers, you have a sticker with asset number. That means that whenever we have a fault, we log the fault against this asset number. And over time, we actually develop, like if it's a common fault that's reoccurring all the time on this asset, it may mean that this asset is a problem. There's a problem, continuous problem. We need to replace it. And also, besides keeping track of these assets, we need to know what these assets have. So for example, the make, the model, the amount of the hard drive, the CPU, the memory, the network card, all those kind of hardware components. Because if you see an important article in the news to say that all hardware with this particular network card is susceptible to some sort of attack, how do you know which computers you have that might contain this particular equipment? Okay, maybe there's an update that needs a driver update to fix that problem. How do you know which ones to apply to? You get me? So asset register is very important from security, from fault logging, and for actually being able to do planning. Because if you have in your asset register that these computers were bought in 2015 and now it's 2020, it's end of life, we can go find all those assets which are at the end of life and replace them. You get me, guys? So this asset register is very important to keep in any organization. So what do you have to do? What you have to do is basically create a table. Create a table. Obviously, you have the headings on the table. Okay? What information you're going to have? I would assume that you're going to have the asset number, first of all. It doesn't have to be a number. You can see that on our example of the sticker, there's some letters and numbers. It's like a student ID. It has to be something unique, hasn't it? There may be the hardware, like CPU, RAM, hard drive, operating system. Okay? Year purchased, the make, the model. Okay? Stuff like that. And obviously, the next thing is that there's actually some software I want you to investigate. All right, so basically, here's a list of software. So what I want you to do is actually, they're all free. What I want you to do, there's only 1, 2, 3, 4, 5 that I want you to actually have a go at using. And but not using it to any advanced level, just using it, see what kind of information you get. So for example, this MS Info is this piece of software. Whoa, okay, so what's this telling us? Whoa, with this, it's I don't need to go find out those information that I wanted to know for my asset register, do I? I can actually go to this software and run it. And look at that, it's telling me exactly what operating system, what version, the system name, the manufacturer, the model, the amount of RAM, and if we look at more components, if we look at storage, for example, we can look at what drives are mapped and all that kind of stuff. But so what's good about the software? It's good is it gives us a lot of information. It's part of Windows. It's free. But what's bad about it? It only tells me about the computer that's in front of me, isn't it? So really, what does that mean if I want to find out all the information of all the computers in this room? I have to go on each one of them and run that piece of software, don't I, to get that information? So really, maybe that's okay, but maybe it's not. Maybe some of these other software will allow me to actually run it from one computer and detect all of those computers, assuming I have the privilege. Okay, so even though that gives you good information, maybe it's not very good for using in a large environment. So with these software, you just need to do a bit of a research, describe what it does and what it does well, like I just gave you, what it does poorly, and do you recommend it for this company to use? Okay, in this company, there's 67 computers, some servers. It's yeah, probably no, because it's a lot of work for the administrator to go around to every computer to run it. I'd rather use something that's more central, as in something that's I can run from one computer and get the information remotely. Okay. So now backup. So we spoke about backups in the last subject as well, but this time it's going to be a little bit different. You'll see that it's still a backup strategy and still talking about the Active Directory and standard company data, but then it's going to talk about how would you protect your company from ransomware, even if your backups were encrypted. Okay. Backup mediums. Okay, so you have to compare the off-site or on-site backup mediums and what backup software, the different types of backup. These are things that are similar, and then we configure the actual backup to backup Active Directory. But unlike last time, this time you're going to do a restore for me as a demonstration to me during the class. Okay. And when we're talking about demonstration, it's not just blah blah blah. Here it is. It's doing it and explaining and answering questions. It's like you're trying to show your customer what is possible. Okay. So now here's another bit of a research anti-malware, antivirus that can be used on Server 2016. Okay. Download a free copy, even if it's a trial copy. Install on your Server 2016. Research the licensing. Is it free? Does it cost per computer? Does it cost per site? What's the cost structure? Does it also, if you pay for it or if it's free, does it include anything else besides just an antivirus? Does it have firewall functionality? Does it have network monitoring or IDS, intrusion detections functionality? Any other features that you find particularly interesting that you want to make sure that we know of this? So then we're going to, again, install this piece of software that you've doing research on that works on Server 2016, and you're going to install it on your server. You're going to make sure it's updated, and then you can demonstrate it to me that it's working. The next part is the file optimization. We're going to learn about DFS, like we mentioned. We're going to replicate the files between the Adelaide file server and the Elizabeth file server, and we're going to implement a quotering. So last time we spoke about quotas, but this time we're going to actually learn how to do quotering, and we're going to implement it, and we're going to actually run a storage report as well as use that file screening, which prevents certain files from actually being stored onto the file system. And obviously you're going, well, that sounds a bit over the top, over my head. Well, let's put it this way. There's nothing in here that's in the core section that's in this assignment that's not in your worksheets. Okay, it might not be exactly the same, like as usual. It might be something similar. You just have to adapt it to your situation, just like if you were doing this real life, right? You're not going to get every instruction for everything you have to do in real life. You have to take what you know, what you've learned, something that's similar, and adapt it to the new situation. That's what competency is all about. Next thing is encrypted file system, so EFS. So it's all about encryption, how we encrypt the file system, and also auditing. Remember we spoke about the 3 A's of security, authentication, authorization, and the third A is the accounting or auditing. Okay, which basically authentication is proving who you are. Authorization is what you can access, what level of access you get to things, and auditing is basically keeping a log of who's accessing what, even if they do have access. All right, so that's what we're going to configure there. Then with the services, we're going to configure your read-only domain controller as a secondary DNS to your domain. You're going to configure DNS to forward lookups. So we've already done that in our first worksheet. We're going to configure the 2 different remote access servers to basically connect to the internet, first of all, the bridge network, and secondly, to actually connect the two networks together, as well as allow remote access. Then we're going to take the Adelaide RAS and we're going to make it into a web server. And we're going to have two websites, a public website, which means anyone can access, no authentication required, and just like an information website for the public. But then there's a private one where in order to get to this one, someone has to put their username in, password in, and they can't access it unless they do that. And it's also been secured by HTTPS. Okay, again, we're going to learn about this. You'll see that just like the previous one, if you started from day one, you'll be learning things as you go along the way. And once you learn something, you practice in the worksheet, you implement it in the assignment, and you get me to check it off. So with the we're going to learn about the firewall as well, Windows Firewall, the default firewall. And we're going to learn how we can actually configure the firewall. So instead of just turning it off like we've been doing, just to make things work, we're going to actually leave it on and open up the firewall accordingly to actually allow the things we do want to go through, but still blocking everything else. And yeah, so that's a couple of things. And there's server hardening. So this is a bit of research again. You're going to do a research on server hardening techniques for web servers or Microsoft web servers, not any web servers, Microsoft IIS. And you're going to implement a particular server hardening technique to your web server. Next one is again, bit of research. You go to this website. There's all free tools about network monitoring. Pick 3, and again, do a bit of summary similar to before. And with one of these tools, demonstrate it to me. What does that mean? Just basically as if I don't know this software, but you're sort of trying to, it's like I'm your supervisor, you're trying to show me that's something you want to implement on our system. Just show me what it is, how it works, and what it does. Okay? And then there's a test plan. You'll see that when I mark your assignments off, I'm not going to mark it on a piece of paper this time. I'm going to be marking on your virtual machines as you go along. When I go off to make something, when I go to mark something and check it's working or not, I'm going to do a procedure. Okay, there's a couple of things, like for example, if I want to make sure that your DNS is working, for example, I might just go onto a computer, do an NS lookup. If I want to test that your DNS is forwarding to the internet or to Google, I might do a NS lookup for a public URL like Facebook or something like that. So here, so you'll notice that it doesn't matter which person I go to, I'll do the same procedure because I know what I'm looking for. I know the procedure. I know what the results I should be getting. And if I'm getting these results, that means it's working. If I'm getting these other results, then it's not working and we need to work out why. So basically that's what's called a test plan. And to be honest, how do you know what you've done is correct? Okay, I might be doing 100 different things, but how do I know that what I've done actually is correct and it works as I expect? That's what a test plan is all about. You don't hand over a product to your customers without adequately testing yourself to make sure it's actually working. You get me, guys? It's just like if you give your customers this completed work and you think it's wonderful, and it turns out that half the things that they wanted aren't working. That's a bit embarrassing, isn't it? So a test plan is really for you to check before you hand it over to confirm things are working. So you need to describe what this is, what the test protocol is actually the procedure, what do you expect to see, and did it pass or not? Okay, so for these things. So here's the appendix with all the users and stuff that you've sort of seen before. So that's what assignment part 2 is all about. Network build, virtualization. So like I sort of alluded to just before, I'm not going to check your assignment right at the end of the semester or term on a piece of paper. So what's going to happen this class is that we're going to start it today. So what we're going to do is we're going to start it today. So if you remember, we spoke about the golden master idea last subject, and in fact there's another video for the golden master later on. But basically a golden master is a template, and we want to make sure that that template is ready to go to create all these servers quickly. if you remember, one of the key things about the cloning is that the computers are identical, and we even made a big deal out of it in the second assignment from the 5ICW, where you had to research the problem where there was a duplicate SID. Okay, so remember we used the PS-Get SID tool to actually confirm the SIDs, but we use the sysprep to change the SIDs. So that should be part of your golden master. You shouldn't have to change a SID after you make a clone. That's it. That's what you want to achieve. So have a look at that video for the golden master if you forgot. But basically, you create the virtual machine with the common virtual hardware. You install the operating system, just the base operating system, not anything else. You install the VMware tools. You actually start the sysprep. When it shuts down in the middle of sysprep, you take a snapshot. That's your golden master snapshot. And then from that, you make clones. And when it clones, it will actually finish off that sysprep and you'll get a different SID. You go into that virtual machine and you change things according to what your virtual machine is going to become. We're going to use link clones. If you remember back to 4IVM, link clones base their files onto the parent. This helps us by saving space. Okay, if you had 6 servers like this, you're going to end up with at least 60 gigs of data, minimum, if not more. And by the end of this assignment, you probably end up with 120 gigs. That's a lot. But if you actually use this link clone method, each virtual machine is only going to be a few gigs. So it's going to save you a considerable amount of space. So therefore, once you create that golden master, you do not turn it on, you do not touch it, because if you break the golden master afterwards, it breaks all your clones. Okay, as some of you might have found out in the previous subject. So what do I want you to achieve today? So if you don't know if we look at this checklist, okay, there's a whole heap of checklists. You can see right now, if we look at Alfred, sorry Alfred, I'm making you an example. We're going to look at Alfred. We're going to, here's all the checklists. Okay, so today what we're going to do is we're going to check that you've created your golden master. We're going to check that all your virtual machines are linked clones. We're going to check that you're using the right IP addresses according to what I give you. We're going to check that your virtual machines have the right software, virtual hardware, the amount of virtual network cards, the amount of hard drives, etc. We're going to check that your server names are named according to the company policy. We're going to check that your domain name is named after the company policy. And that's where I want you to get to today. All right. So by the end of today's lesson, you should have a golden master plus all your link clones with all the names and IP addresses configured correctly before you go. Okay. So we're going to have about an hour and a half to get this done. Once you create the golden master, it doesn't take too long after that. You know where the ISOs are. Okay. Use the valuation ISO so you're not wasting your serial numbers on them. And that's what I'm going to check off today. So hopefully everyone's brought their portable hard drive, because you need to bring your virtual machines to class every lesson now, because there'll be some time for you to work on it and get things ticked off every lesson. So that's what we're working towards, guys. Work towards creating the golden master and creating the virtual machines link clones.